So we're going to further investigate some exponentials in their graphs, and we're going to perform various transformations on exponentials. So if you are unfamiliar with some of these transformations and their rules, I would encourage you to go back to see transformations of functions. So as we begin to introduce new functions, we're going to learn about their transformations as well. So just recall the parent functions of absolute value of x, x squared, radical x, and all of those functions that we worked with in the past in their transformations. The rules will apply to the exponentials as well. So now we're just going to introduce those transformations that we're familiar with to a new type of function, an exponential function. So what we're going to do now is we're going to work with the graph of y equals 2 to the x power. We're going to graph this function from -3 to 3. Then we're going to perform various transformations on y equals 2 to the x power. Specifically, we're going to reflect it over the x-axis, and then we're going to write this new equation. We're going to reflect it over the y-axis, then we're going to write this new equation. We're going to reflect it over the line y equals x, then we're going to write this new equation. We're going to translate it in a y direction, we're going to translate it in an x direction, and we're going to dilate it. And we're going to see what the new equations look like. So let's first work with the graph of y equals 2 to the x power and use the graphs to work on the transformations. So to graph an exponential function, let's set up a table of values. The directions ask you to graph from -3 to 3. So I've already set up those x values. So now this is asking you to plug in -3 for x. 2 to the -3rd power is 1 over 2 to the 3rd power, or 1 over 8. 2 to the -2nd power is 1 over 2 to the 2nd power, or 1 over 4. And if you're unfamiliar with how we're getting this, just go back to the negative exponents video and see why it's a reciprocal. Otherwise, 2 to the -1st power is 1 over 2 to the 1st, 1/2. Plug in 0 now, 2 to the 0 power is 1. Plug in 1, 2 to the 1st is 2. Plug in 2, 2 squared is 4. And plug in 3, 2 to the 3rd is 8. However, you should be recognizing a pattern here. The base of our exponential is 2, which is telling you what's happening to your y values. Each y value is being doubled. So 1/8, doubled, 1/4, doubled, 1/2, doubled, 1, double it again, 2, double it again, 4, double it again, 8, double it again, 16, 32, 64, 128. The base of the exponential is telling you how your y values are increasing. Okay? So let's plot these ordered pairs. Now, these fractions, when you graph an exponential, it's going to be an approximation. So, -3 is our x value, 1/8 is our y value. So we're just going to make it a little above the x-axis. -2, 1/4. Up a little bit more, actually up twice as much, base is 2. 1/2 is 1/2 between 0 and 1, so that's pretty easy to approximate. Now we're working with integers. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. So here is the graph of y equals 2 to the x power. It's exponential growth because the base of the exponential is larger than 1. Okay? So now what we're going to do, we're going to reflect this thing over the x-axis. Here's the x-axis. So all of these values are going to be flipped down there. Let's plot the graph first. We'll plot the graph in red, and then a reflection over the x-axis means that your y values are becoming the opposite sign. So you can do it graphically and just take all of these y values and flip down. Or we can set up a table of values for it. The table of values, since you're reflecting over the x, again, if you're unfamiliar with the rules, go back to transformations of functions video, we're going to make the y value the opposite sign. So we can just copy these x values over again, but make the y values the opposite sign. -1/8, -1/4, -1/2, -1, -2, -4, and -8. So now we have all of our ordered pairs that we're going to plot. There we go, there we go, there we go. -1, -2, and -8. Oh, that's -4. Whoops. 2, -4. So I should be reading my table of values and plotting them specifically. 3, -8. So here is our exponential graph. However, let's write the new equation for this. If we're starting with y equals 2 to the x power, I'm going to erase these tables of values now that we have both of the graphs plotted, so we can see what the new equation is going to be. If we're starting with 2 to the x power, y equals 2 to the x power, and we're performing a transformation, that transformation is a reflection over the x-axis. Remember, that makes the y value negative. That means we're going to have y equals negative 2 to the x power. Let's just take a look at what this is saying to us. This is very important to know that the base of this exponent is 2, not negative 1. This order of operations is saying raise 2 to the exponent, then make it negative. So the last thing you're doing is making it negative. This is saying multiply by negative 1. In order of operations, make sure you're raising that 2 to the x power, then making it negative. So what this is saying is, we're always negative. Well, that makes sense. Look at the graph. It's always below the x-axis. The y values are always negative. Therefore, the equation of this graph is y equals negative 2 to the x power. Okay, let's move on to a reflection over the y-axis now. We have our table of values, and now we're going to reflect it over the y-axis. Let's plot the graph of y equals 2 to the x power. Here we go. There, there, there. 1, 2, 2, 4, 3, 8. Here's the graph of y equals 2 to the x power. And now we want to graph a reflection over the y-axis. Here's the y-axis. There's our line of reflection, which means this is going over there and this is going over there. Let's plot the graph first. The graph will look like this. Negative 3, 1/4, 3, 1/4. Negative 2, sorry, negative 3, 1/8. Negative 2, 1/4, 2, 1/4. Negative 1, 1/2, 1, 1/2. Let's see, 1, 2, negative 1, 2. Is 2 boxes over? 2 boxes over. 3 boxes over? 3 boxes over. So there's a reflection over the y-axis. Remember that exponential graphs have horizontal asymptotes. They never cross the x-axis yet. So let's see what this equation is going to be. I'm going to erase my table of values, and if I wanted to set up a table of values for my new graph, what I would do, I would have x and y values. A reflection over the y-axis is asking you to make the x value negative. So I'm going to change the signs of these and leave the y values the same. So I'm going to leave my y values alone, just copy them over again. But I'm going to make the x values the opposite sign. 3, 2, 1, 0, negative 1, negative 2, and negative 3. So here are all of my ordered pairs for that graph. So I'm going to erase the table of values to see what the new equation is going to be. So I started with y equals 2 to the x power. There is a transformation occurring. That transformation is a reflection over the y-axis. So reflecting over the y is actually to change the x. So that's exactly what I'm going to do with my equation. Make the x negative for an ordered pair, so you make the x negative for the equation. Y equals 2 to the negative x. So you may be saying, well, you said that exponential decay, that's what this is, exponential decay, when we read from left to right, it's getting smaller and smaller. The base has to be less than 1. This base is 2. Or is it? Take a look at the negative exponent. The negative exponent is asking you to take the reciprocal of the base. So this can also be expressed as 1/2 to the x power. So if you take a look, the negative exponent, it's saying that the base is less than 1. So this is exponential decay because the base is between 0 and 1. Move on to our next transformation. Now we're going to reflect over the line y equals x. Our good old friend inverse. That's what we're doing here. So since we're finding the inverse, we're going to flip x and y. The x values become y values, the y values become x values. You're not making anything positive or negative or anything different for that matter. You're just interchanging the x and y values one ordered pair at a time. Okay, so let's plot the graph y equals 2 to the x power. When x is 1, y is 2, 2, 4, and 3, 8. So here's our graph. And now we're going to reflect over the line y equals x. So I'm going to draw the line y equals x just so I can kind of look forward to see what my graph is going to look like. So let's plot the line y equals x. The line y equals x looks like this. So now what's going to happen here is you can take a look and tilt your head to see, all right, so my graph looks like this. I'm reflecting over this line, so we're going to have something that looks like this. There's our line of reflection. This is our line of symmetry. So now this is going to end up over there. This is going to end up over here. Okay? So reflecting over the line y equals x is asking you to change x and y. So I'm going to set up a table of values for this. My first order pair is -3, 1/8. What's my new order pair? 1/8, -3. Let's plot it. 1/8 means go over a little bit, not a lot, just go right a little bit and go down to -3. There's my first order pair. My next order pair was -2, 1/4. Switch x and y. 1/4, -2. Go over a little bit more, but just go down to -2. -1, 1/2 will yield 1/2, -1. So go halfway between 0 and 1, x value, and down -1. 0, 1 was the order pair for the blue graph. If I'm flipping x and y, I end up with 1, 0, 1, 0. Order pair is 1, 2. So my new will be 2, 1. My new will be 4, 2. My new will be 8, 3. So I'm going to plot all those order pairs now. 2, 1, 2, 1. 4, 2, 4, 2. And 8, 3, 8, 3. So now let's take a look at this. If we're reflecting over the line y equals x, take a look at your x values here. None of them are negative. None of them are 0. Which means this graph never crosses the y-axis. There is our new graph. And if you look at it, take a look. Does it look symmetrical? Yes, that is the image of our reflection over the line y equals x. So this is the inverse of the exponential. So now let's write the equation. We started with a function y equals 2 to the x power. We performed the transformation. That transformation was a reflection over the line y equals x. To write the equation, you do exactly what you did to the ordered pairs. The ordered pairs, we switch x and y. So that's what you do to the equation. We're going to switch x and y. Not y equals 2 to the x equals 2 to the y. Now typically when you find an inverse, you have to solve for y. We do not have a tool for that yet. That's in a couple days. For now, the equation is x equals 2 to the y power. So that's how I'm going to write this. This is x equals 2 to the y power. And this is y equals 2 to the x power. Now let's work on some translations. We're going to translate this graph in a y direction. So if you remember what the translation in the y direction, that was after the function. So the last thing you're doing is adding 2. So we're going to add 2 to all the y values. Let's plot the graph of y equals 2 to the x power first. Oops. Let me get rid of that. 1, 2, 2, 4, and 3, 8. So here's the graph of y equals 2 to the x power. So now if you remember what a translation is doing. A translation, this is a y value, and that's an x value. So the x value is 0 here. If we want to translate this thing, 0 in an x direction and 2 in a y direction. So really what we want to do is take the same exact graph, and lift it up 2 units. Okay, we're going to go up 1 unit, 2 units. So that's what our graph's going to look like. We're translating in the y direction, 2 units, same sign. X value is the opposite sign. So we're going to move this up 2. So now, in order to graph this, because you don't have a cloning feature on your pen and paper, this is actually just add 2 to all the y values. So add 2 to all of your y values here, and then replot your graphs. For example, 3, 8 is now 3, 10. 2, 4 is now 2, 6. 2, 6. There it is. Okay? Let's write the new equation now. The new equation, we started with y equals 2 to the x power. We performed the transformation. That transformation was a translation of 0 in an x direction and 2 in a y direction. So that's what we do to the equation. We're adding 2 after everything. So your new equation is y equals 2 to the x plus 2. I'm adding 2 after everything. So now in an x direction, if you remember, if we want to translate 2 in an x direction now, that's inside of the function, but the opposite sign. So now let's see what inside of the function is. This function calls for you to raise something to a power. So that's the function. The function is the exponent. So inside of the function is inside of the exponent. Okay, so let's plot the graph y equals 2 to the x power and then move it in an x direction 2 units. 2, 4, and 3, 8. So here's our graph. This is y equals 2 to the x power. And all we're going to do is take this graph and we're going to move it 2 in an x direction. So positive 2, right 2. 1, 2. There's a new graph. So let's see what the new equation would be. If we're starting with y equals 2 to the x power, and we're performing a transformation, that transformation is a translation of 2 in an x direction and nothing in a y direction. It's just moving left and right. So it's moving positive 2 in an x direction, which means in the equation it's a negative 2. Remember, when it's left and right, horizontal translation is the opposite sign. So we're going to end up with y equals 2 inside of the function x minus 2. I'll write that a little bigger so you can see it. Y equals 2 to the x minus 2 power. That's inside of the function, inside of the exponent, because this is an exponential equation. Inside of the quadratic was before you squared it. Inside of the absolute value was before you took the absolute value. Inside, in this case, is before you evaluate the exponent. So this is a translation of 2 in an x direction, because it's the opposite sign. And the last transformation is a dilation. Here are ordered pairs for y equals 2 to the x power. Let's plot that. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Here's my graph of y equals 2 to the x power. So now this is going to change the shape of the graph. The shape of the graph here, this is telling you to dilate it 2. That means you're multiplying the y values by 2. So I'm going to rewrite the table of values here. X, y. My x values will remain the same. My y values are going to be doubled. So I'm going to multiply all of these by 2. 1/8 times 2 is 2/8, or 1/4. 1/4 times 2 is 2/4, or 1/2. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So this order pair is not going to fit in the graph anymore, but the rest of them I can fit. So negative 3 1/4. Negative 3 1/4 is just up a little bit more. Negative 2 1/2. Negative 2 1/2. Just up a little bit more. Negative 1 1. Negative 1 1. Up just a tad more. 0 2. 1 4. 1 4. And 2 8 is the last one that'll fit. 2 8. So here's my graph. If you recall, a dilation stretched it towards the y-axis. It brought it closer to the y-axis for the absolute value, for the quadratic, and for the radical graph. It brought it all closer to the y-axis. That's exactly what it does here. So let's write the new equation up. So we were dilating 2, which means we're multiplying by 2. So that's exactly what we're going to do to the equation. We started with y equals 2 to the x power, but now we're multiplying by 2. Most important thing here, just like y equals negative 2 to the x power, you cannot combine these before you raise it to the exponent first. Same thing here. This is not y equals 4 to the x power. This is y equals 2 times 2 to the x power. You cannot multiply these things first, which is why it's important to use parentheses when you're trying to express a dilation. And as we continue with some applications of exponentials, you'll see where this applies. 2 times 2 to the x power. So let's just compare this to compound interest. Initial amount